I am S. Annapurani, Assistant Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchenkoot. The course name is Laplace Transform and Complex Variables. In this course contains 5 modules. One of the module is analytic functions. From this analytic function, we have to see construction of analytic functions. First, we have to see the Millen-Thomson method. Millen-Thomson method is nothing. This method is used to find the analytic function f of z. If f of z equal to u of x comma y plus I into v of x comma y, then Millen-Thomson method is used to find f of z. Here f of z is the analytic function. If they given only u of x comma y or v of x comma y, then how to find out the analytic function by using Millen-Thomson method. Here u of x comma y is real part and v of x comma y is a imaginary part. Next, let's see the construction of analytic function by using Millen-Thomson method. If they given the real part value, what is the formula to find the analytic function? And if they given the imaginary part value, that is v of x comma y is given, then what is the formula to find the analytic function by using Millen-Thomson method? We have two cases. Let's see the first case. If they given real part u of x comma y, then what is the formula? First we have to find out ux. Ux is nothing. Differentiate partially u value with respect to x. Then you can get dou u by dou x. Shortly you can write ux. Then another one is you have to find out uy. Uy is dou u by dou y. After that, let us take ux as phi 1 of x comma y and uy as phi 2 of x comma y. Then finally, the analytic function f of z is integral pi 1 of z comma 0 minus I into pi 2 of z comma 0 into dz plus c. Here we have to put z value for x and 0 value for y. Then you can get pi 1 of z comma 0 and pi 2 of z comma 0. Pi 1 of z comma 0 value you can get from ux and pi 2 of z comma 0 value you can get from uy. Here c is an arbitrary constant. Next, let us see the imaginary part. If they given imaginary part v of x comma y, then what is the formula to find the analytic function by using Millen-Thomson method? If they given v of x comma y, you have to find out vy value and vx value. Vy is nothing. Differentiate partially with respect to y, that is dou v by dou y. Another one vx is also differentiate partially v value with respect to x. Then you can get dou v by dou x value. Shortly you can write vx. Next one, let us take vy as pi 1 of x comma y and vx as pi 2 of x comma y. Now see the analytic function formula. Then f of z is equal to integral pi 1 of z comma 0 plus I into pi 2 of z comma 0 into dz plus c. Already we know c is an arbitrary constant. Here, if you want to get pi 1 of z comma 0 value, then put z value for x and 0 value for y. Then finally you get pi 1 of z comma 0 from vy and pi 2 of z comma 0 from vx. Next, let's see the one problem. Say, construct the analytic function f of z equal to u plus iv given that v equal to x power 4 minus 6x square y square plus y power 4. In this problem, they given imaginary part value. We already know the formula. That is, the imaginary part is given means first you have to find out vy and next you have to find out vx. Vy is nothing, pi 1 of x comma y and vx is pi 2 of x comma y. After finding pi 1 of x comma y and pi 2 of x comma y, you have to put z value for x and y value, 0 value for y. Let's see, first step is given value v. b equal to x power 4 minus 6x squared y square plus y power 4. In this imaginary part contains three terms. First term is x power 4, second term is minus 6x squared y square plus third term is y power 4. First you have to differentiate partially with respect to x, that is Vx value. Vx equal to differentiate the first term x power 4. So differentiation of x power 4, we already know one formula. Differentiation of x power n equal to n into x power n minus 1. So therefore differentiation of x power 4 equal to 4 into x cube. Differentiation of here, differentiation of first term is 4x cube. Then second term minus 6x squared y squared. Here x squared is only a variable, remaining minus 6y squared is a constant term. So differentiation of x squared is 2x, multiply along with minus 6y square, you can get minus 12x into y square. From b, the third term is y power 4. Differentiation of y power 4 is 0 because y power 4 is a constant term. We already know the formula for differentiation of constant term is 0. Therefore, finally we get Vx equal to 4x cube minus 12x y square. After that, you have to find out Vy, that is differentiate V partially with respect to y. The first term is x power 4. So x power 4 is a constant term with respect to y. So the first term will be 0. Then differentiate the second term. Second term is minus 6x squared y squared. Here y squared only variable. So differentiation of y squared is 2y. So multiply 2y along with the minus 6x squared. So finally you get minus 12x squared y. Then third term is y power 4. Differentiation of y power 4 is 4y cube. Finally we get Vy equal to minus 12x squared y plus 4y cube. Now let's see. Vy is, we already know Vy, let us take Vy as pi 1 of x comma y and Vx as pi 2 of x comma y. Before finding the value, first we have to put for x value is z and y value is 0. Then substitute those values in this Vx and Vy. You can get Vx equal to 4x cube minus 12x into y squared. For x value z cube, z value, and for y 0. Vx equal to 4 into z cube minus 12x into y squared value is 0. Therefore Vx equal to 4z cube. Vx equal to, you can get 4z cube, that is Vx value is pi 2 of x comma y. Finally we get pi 2 of z comma 0 equal to 4z cube. Then substitute, next find out the pi 1 of x comma y. So put is x equal to z and y equal to 0 in Vy. See, Vy value is what is minus 12x squared y plus 4y cube. Both the term contains y value. Substitute y value as 0. Finally you get Vy equal to 0. Therefore pi 1 of z comma 0 equal to 0. Substitute those values, that is pi 1 of z comma 0 equal to 0 and pi 2 of z comma 0 equal to 4z cube. Substitute in this Millen-Thomson method formula. We know the Millen-Thomson method for imaginary part is f of z equal to integral pi 1 of z comma 0 plus I into pi 2 of z comma 0 dz plus c. Pi 1 of z comma 0 value is 0. See here, pi 1 of z comma 0 is 0 and pi 2 of z comma 0 equal to 4z cube. Substitute those value here. So integral first term pi 1 of z comma 0 is 0. So first term will be 0 plus I into integral pi 2 of z comma 0 value is 4z cube. Substitute those value. So 4z cube into dz plus c. Finally we get I into integral 4z cube dz plus c. Now integrate 4z cube. We already know the formula. Integration of x power n is x power n plus 1 divided by n plus 1. Substitute. Now we get the formula. Integration of z cube equal to z power 4 divided by 4. So therefore finally I into 4 z power 4 divided by 4. You can cancel the 4 and 4. Finally we get I into z power 4. Therefore the analytic function f of z equal to I into z power 4 plus c. This is the method to find the analytic function by using Millen-Thomson method. Thanks for watching.